In Notes 5.4, we're going to learn how to name ionic compounds. We've already talked about writing the proper chemical formulas for ionic compounds, so now we're going to look at, if we're given the formula, how do we name it? Some background information on naming. When we name compounds, we use something known as the IUPAC nomenclature. Okay, the IUPAC stands for International Union of Pure and Applied Chemistry. Okay, and what this is it is a systematic approach to naming compounds. Because it is international, the same names are used worldwide. Many of the substances we use in lab or in our basic chemistry class have common names associated with them. Things like baking soda, table salt, quicksilver, laughing gas, etc. The problem with common names is that they don't tell us anything about the chemical composition of the substance. So for example, if I told you lye, which is a substance found in many cleaning substances, is actually sodium hydroxide, NaOH, you now have a better understanding about what the composition or the chemical makeup of lye is. And so we want to make sure that the names that we are using are the systematic names that give us an idea about the makeup or the chemical composition. So there are two types of ionic compounds that you guys will need to know how to name. The first one is known as a binary ionic compound. The prefix bi means two, and so a binary ionic compound is a compound that has two different ions. Because it's ionic, one of the ions is going to be a metal and one will be a nonmetal. Or one of the ions will be positively charged because it lost electrons, and the other will be negatively charged because we gain it. When we name the binary ionic compounds, we're going to name the cation and the anion separately. So all ionic compounds will have two words in their name. The first name is going to be the name of the cation. The second part will be the name of the anion. So when we name the cation, and remember cations are positively charged, so they are written first in the chemical formula, we're simply going to use the name of the element. So on the front side of our periodic table, we will just look up what the name of the element is. So if we're given the element symbol Ca, we can tell that Ca is actually called calcium. So we would name it as calcium. When we name the anion, which is the second element or the negatively charged element, we're going to use the name of the element, but we're going to change the ending to IDE. So change the last three letters of that element symbol on the front side to IDE. So for example, O on the front of the periodic table is called oxygen. However, in a compound or in an ionic compound, it loses 2 electrons, so it gains 2 electrons, so it has a -2 charge. So we would call it oxide. Notice I changed the ending, in this case the last 3 letters, to IDE. F is fluorine. However, in an ionic compound, we would list it as fluoride. Okay, so the general rule of thumb is the anion is going to be the name of the element, but the ending is switched to IDE. Okay, now the only time this can get a little tricky is if we're talking about a cation, so our positively charged ion, that has more than one oxidation number. So if you recall, we talked about oxidation numbers in our last unit, or in the last video when we wrote formulas, and we said elements in group 1 have an oxidation number of +1. Elements in group 2 are +2, group 3 are +3, and then we got into our -3, -2, -1 for groups 5, 6, and 7. What we didn't address were those transition elements, or those elements that are found in that middle section of the periodic table. These elements can have multiple oxidation numbers, and if we take a look at the key, we can see that the multiple oxidation numbers are listed right above the element symbol. And so we need to know which of those oxidation numbers we're using. Okay, and we'll talk about how to figure that out in a little while here. But for now, recognize that if we're dealing with an element found in that middle section, so any of the transition elements, we have to include Roman numerals. And those Roman numerals indicate what the charge of the ion will be. So if I'm dealing with a compound that has iron with a +2 charge, then I would call it iron Roman numeral 2. If the iron in my compound has a +3 charge, we would call it iron, Roman numeral 3. And again, I'll show you in a minute how to decipher that. Now, there are a couple of exceptions to this. And so if you take out your periodic table right now, if you need to pause the video, do so. I would like you to take it out, and you will see that I have bolded some elements here. Okay, so in the transition element section, I've bolded zinc, cadmium, and silver. Okay, so I would like you to draw boxes around those 3 elements. And then you will notice in group 4, I've also bolded tin and lead. Okay, so these elements stand out because they are exceptions to our rules. So for the middle section, the zinc, the cadmium, and the silver, these elements here only have 1 oxidation number, so they do not need Roman numerals. Okay, so all of the elements in that transition or that middle section of the periodic table should have Roman numerals except zinc, cadmium, and silver. So any of these 3 that are used, I could simply just name it as is without worrying about Roman numerals. Okay, in group 4, none of the elements need Roman numerals with the exception of tin and lead. So tin and lead are highlighted because these 2 can have multiple oxidation numbers, so they need Roman numerals. Again, the periodic table that you're given on any test or quiz is always going to have these elements highlighted so that they can draw attention to them. You just need to recognize that the middle ones don't need Roman numerals. The ones in group 4 do indeed need Roman numerals. Okay, so let's take a look at how this works. So the first thing I'm going to do is name the compound MgO. Okay, MgO is a binary ionic compound because it consists of 2 elements, magnesium and oxygen. Again, when we name it, we break it apart into the cation and the anion. The cation, or the positively charged ion, is the magnesium. And so I'm going to name that exactly as it is, magnesium. Mg on the front of the periodic table is called magnesium. Okay, on the front of the periodic table, O is called oxygen, but since it's the anion or the second ion, we change the ending to IDE. And so the name of this compound is simply magnesium oxide. Okay, if we look at examples 2 and 3, we can see that when we name these, we are dealing with elements such as iron and lead that can have multiple oxidation numbers. And so we have to pay attention to that. So FeCl3. Fe is my cation, so I'm going to name it as is, iron. But recognize iron is found in that transition element section of the periodic table, which means iron can have multiple oxidation numbers. It can have multiple charges. It can accept 2 electrons in some situations, 3 in others. So we have to include Roman numerals in our name. To determine what the charge of this iron atom is, we are going to look at our anion, or the negatively charged ion. Chlorine is found in group 7, which means it has an oxidation number of -1. I have 3 chlorines based on this formula. So if I add that all together, -1 plus -1 plus -1, I get a grand total of -3 in this compound. Remember, ionic compounds are electrically neutral. So if the chlorine has a -3 charge, then there's 1 iron, so that iron has to have a +3 charge to offset the -3 so that the overall charge is 0. So when I go to name this, I name this as iron 3, Roman numeral 3, and then chlorine becomes chloride. So the proper name for FeCl3 is iron 3 chloride. Okay, we're going to do the same thing for our next example, PbS2. Pb is my cation. Okay, when I find it on the periodic table, I'll see Pb is called lead, so I'm going to name this as lead. But notice it is one of those elements that's highlighted in group 4, which means it can have multiple oxidation numbers. Okay, again, to determine what the charge of this lead is it lead 2 or lead 4, we are going to look at the charge of the anion. Sulfur here is found in group 6, which has a -2. And there's 2 of them, so -2 plus -2 gives me a total negative charge of -4. Again, I need my compound to be neutral, so this means lead is going to be +4. So when I name this, I'm going to name it lead, Roman numeral 4, and then S is sulfur, but since it's the second element, I change the ending to IDE, so it becomes sulfide. Lead 4 sulfide is the proper name. Okay, so that's how we name binary ionic compounds. There is also what are known as ternary ionic compounds, and ternary ionic compounds are compounds with polyatomic ions. Okay, remember we have that polyatomic ion reference sheet, so when we name them, we're going to want to have access to that sheet. When we name ternary ionic compounds, we once again separate the cation from the anion and name them individually. These are actually easier to name because we name the cation the same way as the name of the element, but then for the anion, we're just naming it whatever the name of the polyatomic ion is, and that's listed on that reference sheet, so we don't have to worry about changing the ending at all. So if I look at CaCO3, I can recognize Ca is my cation, okay, and the name of Ca on the front of the periodic table is calcium. The anion in this compound is a polyatomic ion, CO3. So we should recognize that all ionic compounds can only break apart into 2 ions. So if calcium is the positive, then CO3, that entire thing, is the negative. And if I look at my polyatomic ion reference sheet, I will see CO3 has the name of carbonate. And so CaCO3 is simply called calcium carbonate. Okay, I could do the same thing for my next example, MgNO3 2. Again, my cation is Mg. That's simply the name of the element. Mg, as we've already established, is magnesium. My anion is this NO3. Okay, it's not breaking it down into nitrogen and oxygen. We treat that whole thing, NO3, as one. And if I look it up on the polyatomic ion reference sheet, I'll see NO3 is called nitrate. So MgNO3 is magnesium nitrate. Okay, my last example, Na is my cation, so it's the name of the element. Na is called sodium. SO3 is my anion. That's found on the polyatomic ion reference sheet, and that is called sulfite. So SO3 is called sodium sulfite, or Na2SO3 is sodium sulfite. Notice, regardless of if it's binary or ternary, all ionic compounds will have 2 words in their name. First word is the name of the cation, second word is the name of the anion.